Hey there, this is Austina and Anushka from the .NET Windows team from VMware Tanzu. We're here to talk about Stembuild, a CLI tool to help automate the creation of Windows BOSH stem cells for vSphere environments. Stembuild recently went GA, so we're here to share some best practices on how you could be getting the most out of it. This is not a full demo of using Stembuild again, so don't worry. For that, you can check out this video series linked on your screen. By the end of this video, you should have clarity on some common misunderstandings and have a good idea of the recommended way to use Stembuild.
Stembuild is a tool that builds BOSH-compatible stem cells for Windows. While for public clouds, you can download a light stem cell directly from BOSH.io or Pivotal Network, with private clouds like vSphere, things are a bit different. Because Microsoft doesn't allow for the redistribution of the Windows operating system by just any provider, vSphere users need to build their own Windows stem cells. Rather than build a stem cell manually, which can be complex, time-consuming, and error-prone, Stembuild automates the process of stem cell creation so that once you've downloaded and set up your base image, it's just two simple CLI commands to create a final stem cell.
Let's dive into the steps for creating a stem cell and some best practices for using Stembuild. You can begin by downloading a standard Windows Server image and lgpo.zip from Microsoft, as well as the Stembuild binary from Pivotal Network or bosh.io. You can find links to lgpo.zip and Stembuild in the description. Here's where our first best practice comes in. Use a vanilla base image rather than an internal golden image or an image with any customizations baked in. This first best practice will ensure that your build process is supportable, and should you have any issues creating and deploying stem cells, VMware support engineers can recreate your experiences and reproduce any issues you may have. We'll often see long-running painful issues resolve themselves once a golden image is replaced with a plain base image. Customized images are not officially supported by VMware. Starting with a plain base image will create consistency across all of your Windows and Linux stem cells, and any customizations you feel are necessary, such as antivirus software, can be added later as a BOSH add-on. So once you've procured your vanilla base Windows ISO, upload the Windows ISO to vSphere, where you can configure it with the correct network settings and install Windows updates.
Once you have your base Windows image set up in your vCenter, you'll do two things. First, you clone that VM. The new cloned VM becomes your target VM, or the VM you'll be turning into a stem cell. Cloning the base VM will allow you to preserve all the settings for future runs of Stembuild. Once you've cloned the base VM, shut it down. This will allow you to use the same IP for your target VM. Now comes the fun part. Ensure that you have Stembuild and lgpo.zip in a directory on your local host, or wherever you're running Stembuild from. You'll run Stembuild construct first. This step configures the target VM with the proper registry settings and policies. It updates your root certificates as long as it has access to the public Windows Update server, and installs the BOSH agent onto the VM. Stembuild does all of this by connecting to the target VM using WinRM, and wraps up by disconnecting WinRM, disabling it completely, running sysprep, and shutting down the VM. Note what I said there. Stembuild will automatically shut down the VM, and this is where best practice number 2 comes in. Don't shut down your target VM manually. Manual shutdowns can result in incomplete syspreps and can prevent the stem cell from being created properly. This often manifests itself as failing Windows cells post-deployment. It looks like the VM continuously failing and the BOSH director continuously trying to resurrect it. If Stembuild construct is hanging, ensure that you've logged off all users from the target VM. If you have to shut down the VM yourself, it's likely that there's something else going on that's preventing Stembuild from executing successfully.
We've seen Stembuild construct successfully configure and shut down the VM. Our next step is to run Stembuild package against the powered off VM. This will download the VMDK file and convert it into that final stem cell. Finally, you'll upload the stem cell to Ops Manager and deploy our TASW or TKGI tile. This is where the final best practice comes in. To access your VM, you should always use BOSH SSH, not WinRM, RDP, or Remote PowerShell. Always BOSH SSH. In fact, all of these other options are disabled by default on Windows VMs. They're just too insecure in a Windows platform.
Here, We bosh SSH into our test deployment and see the creation of this user. When we print the contents of this directory, we can see a full user directory. Now we exit the SSH session and start a new bosh SSH session. We can see now that there are seemingly 2 users present. When we print the contents of the newly created user, we see a full user directory, but when we print the contents of the old user, we see that everything has been deleted.
And with that, we've made it through all of our best practices. In summary, use a vanilla base image, avoid manual shutdown, and access Windows VMs post-deployment via bosh SSH. Hopefully this video has answered some of your questions or has helped you understand how to use Stembuild to optimize your experience with the tool. Thanks for watching.